Hello. So in this particular question we are given 3a minus b is equals to 5011. So this is a matrix and we are provided with the value of the matrix B. So using this too, we have to find out the value of matrix A. So let's begin with the first matrix equation. It's given that 3a minus b is equals to 50 in the first row and 11 in the second row. And we're also provided with the value of matrix B, which has the elements 4 and 3 in the first row, 2 and 5 in the second row. So in order to find out the value of A, what we'll do is we're going to substitute the value of B into the first equation, the first matrix equation. So this will give us trace of A minus 4, 3, 2, 5. And this is equals to 5, 0, 1, 1. Now we will transpose the matrix B to the right hand side. That will give us 4, 3, 2, 5 plus 5, 0, 1, 1. Now we see that both of the two matrices are of the same order. They are of order 2 by 2 and 2 by 2. So what we can do is we can add the corresponding elements, meaning we'll be adding the first element of the first matrix to the first element of the second matrix. So this is 4 plus 5. And for the second element, we'll have 3 added to 0. For the third element, we have 2 added to 1. And for the fourth element, we have 5 added to 1. So let's simplify this. So this should give us trace of A equals to 4 plus 5 is 9. 3 plus 0 is 0. 2 plus 1 is 3. And 5 plus 1 is 6. Now what we're going to do, we're going to divide both sides by A. So that is 1 over 3, 9, 3, 3, 6. Now, since 1 over 3 is a scalar, so what we can do, we can divide each entry by 3. So that will be 9 over 3, 3 over 3, 3 over 3, and 6 over 3. So when we further simplify it, that should give us 3, 1, 1, and 2. So that's it. So this is how we can find out the value of matrix A. So let's go to the next question. So here we have a matrix equation that's given to us. Now using this information, we have to find out the value of x minus y. So what we'll try to do, we'll try to first find out the value of x and y. So let's rewrite this matrix equation. So this is 2 times 1, 3, 0, x plus y, 0, 1, 2. This is equals to 5, 6, 1, 8. So for the first matrix, 2 is a scalar, so we're going to multiply each entry by 2. So that should give us 2, 6, 0, twice x. Plus, we'll rewrite the other remaining matrices. Y is 0, 1, 2. This is equals to 5, 6, 1, and 8. Then we're going to add the first two matrices because they are of the same order, which is 2 by 2, 2 by 2. And let me write it here as well. This is also a 2 by 2 matrix on the right hand side. So we'll have the first entry as 2 plus y. 6 plus 0 is simply 6. 0 plus 1 is simply 1. And we have twice x plus 2. So this will be equals to 5, 6, 1, and 8. Now since the two matrices are equal, so that means the corresponding entries must be equal. So what we can do, the first entry, which is 2 plus y, this will be equals to 5. And if we look at the fourth entry, which is twice x plus 2, this will be equals to 8. Now, we have already seen that 6 is equals to 6, which is the second entry. We don't have to write it, so that is true. So that will be trivial writing down. So solving for y, that gives us 5 minus 2, which is 3. And solving for x, so this will give us 8 minus 2, this gives us 6, so this gives us x is equals to 3. So we have the value of x as 3 and the value of y as also 3. So according to question, we have to find out the value of x minus y, which is equals to simply 3 subtracted from 3 will give us 0. So that's the answer. Let's move on to the next question. So here we have a square matrix A such that A is of squared is equals to the identity matrix. Now using this information, we have to simplify the value of A minus I raised to the power of 3 plus A plus I raised to the power of 3 minus 7 of A. Okay, let's start. So let's write expression A minus I cubed plus A plus I cubed minus of 7A. So what we're going to do here, we are going to open up this expression. So this is an identity. We're going to use the identity A minus B whole cube is equals to A cubed minus 3A squared B plus 3AB squared plus minus B cubed. And the other identity, which is A plus B whole cubed, this is A cubed plus 3A sub squared B plus 3AB squared plus B cubed. So let's apply that. The first expression will become A cubed minus 3A squared I plus 3A times I squared minus I cubed plus A cubed plus 3A squared I plus 3A I squared plus I cube, and the remaining term, which is negative 7 of A. So here we see some terms which are additive inverse of each other. So the first one is negative 3A squared I and 3A squared y, they will cancel out each other. Similarly, negative I cubed and positive I cubed will cancel out, so since they are the additive inverses of each other. Now what we'll do, we're going to combine A cubed and A cubed. There are two like terms, so that would give us twice of A cubed. And we'll combine 3A's of AI squared. There are two of them, so we'll have 6AI squared. And the remaining term, which is 7 of A. Now, 2's of A cubed can be rewritten as 2 of A times A squared. Then we have 6 of A. Now I squared. So I squared means what? It's identity matrix multiplied to itself. So that will simply give us the identity matrix I. So I'll write here, since I sub squared is equals to I. Now A sub squared, that's given that according to question A sub squared is I. So I've substituted the value of A squared with I. Plus 6 A's of I minus 7A. So we can add the first two terms, so that will give us 8AI minus 7A. Now we know that A is of I, that's the matrix multiplied to an identity matrix, gives the matrix itself, meaning we can simply rewrite it as 8A minus 7A, since a matrix multiplied to an identity matrix gives the matrix itself. So 8A minus 7A, so the final answer is A. So that's the answer to the simplified form of A minus I cubed plus A plus I cubed minus 7A, simply A. Write the number of possible matrices of order 2 by 2 with each entry 1, 2 or 3. So we have to figure out the number of possible 2 by 2 matrices. So we know that our 2 by 2 matrices are going to have 4 entries. So let's call it E11, E12, E13, it's E21, E21 and E22. Now E11 could be either 1, 2 or 3. Similarly, A12 can also take the values 1, 2 or 3. A21, the same case, it can take 1, 2 or 3. And similarly, A22 also can take 1, 2 or 3. So in each of the cases we see, so there are 4 possibilities. So not 4, my bad. There are 3 possibilities, 1, 2 or 3. So there are 3 possibilities. Similarly, for the second entry we have 3 possibilities, and again for 20, the A21, which is the second row first column, that is also going to have 3 possibilities, and the fourth entry is also going to have 3 possibilities. So to find out the number of possibilities, we simply multiply each of the possibilities. So that is 3 times 3 times 3 times 3, which is 81. So that means 81 such matrices are possible. So I can give you one example. That will be the first entry could be 2, the second entry could be 3, the third entry could be 1, and the fourth entry could be 1. Or we can have 1, 1, 1, 1. We can have 1, 2, 1, 3, and so on. So there will be like 81 such possibilities. So we have 3 matrices, the product of which is equivalent to A. So we have to find out order of matrix A. So let us begin. We'll write the matrix 2, 1, 3. So this is multiplied to a 3 by 3 matrix, which is negative 1, 0, negative 1 in the first row, negative 1, 1, 0 in the second row, and 0, 1, 1 in the third row. This is multiplied to another column matrix, which is 1, 0, negative 1. And this is our matrix A. So to begin with, we are going to multiply the first 2 matrices. The first matrix is of order, so this is a row matrix, so this order is 1 cross 3, 3 by 3 matrix. So when we multiply these 2 matrices, so we should get a 1 by 3 matrix. So that means 1 row and 3 columns. So we're simply going to multiply the entries. So this will be 2 times negative 1 plus 1 times negative 1 plus 3 times 0 is 0, so I'm not writing it here. Now we go to the second entry, which will be 2 times 0, which is again 1. Then we have 1 times 1 plus 3 times 1. Then we move on to the third entry, that this will be 2 times negative 1, 1 times 0 is 0, I'm skipping it, and then we add 3 times 1. So this will give us the matrix, which is the product of the first 2 matrices. And we have the column matrix 1, 0, negative 1. So let's simplify it. So this will give us 2 times negative 1 is negative 2. 1 times negative 1 is negative 1, so negative 2 and negative 1 gives us a negative 3. Then we have 1 plus 3, so that should give us 4. And we have 2 times negative 1 plus 3 times 1, so negative 2 plus 3 would give us 1. Then we need to multiply it to 1, 0, negative 1. So I'm running out of space, let me scroll down. Okay. Now we're left with a row matrix, which is of order 1 cross 3, and a column matrix of order 3 cross 1. So when we multiply a row matrix to a column matrix, what we get is a matrix of order 1 cross 1. So that would be simply 3 times negative, 3 times positive 1 plus 4 times 0 plus 1 times negative 1. So this is negative 3 plus 0, negative 1. So we're getting a matrix with only a single entry, which is negative 4. So this is the value of the matrix A. So that means we can rewrite here. So here we'll write, so our matrix A is a matrix of with only one entry. So that means it's a matrix having the order 1 cross 1. Yeah. So order of matrix A is 1 cross 1. Okay, see you in the next section.